Alright, this is lesson 79. Recursive formula and geometric sequences. So, we've talked about two kinds of sequences, arithmetic and geometric. Arithmetic is when it's being added by the same amount every time, right? So if I start with 2 and I'm adding 2 every time, it's going to be 2, 4, 6, 8, 10, 12, right? Does that make sense? And we can assume it's always going to go by 2s. With a geometric sequence, we're saying that it's being multiplied by the same amount. 2, 4, 8, 16, 32, 64, 128, and so forth. Does that make sense? Okay, so we already know that, and then under each of those sequences there's an explicit formula that says if I want to find the explicit number or the specific number for a certain spot in the sequence, I'm going to use the explicit formula. And then we have to learn this one that's called the recursive formula. That's saying, it's a little redundant, it's saying if I want to figure out a specific number, then I need to figure out what's the number before it in order to figure out that number, which just kind of takes a long way around to get there. But we still need to know it because logically that would make sense. You need to know the number before it to get the next one. We're going to touch on recursive formula very quickly, and then we're going to do the second objective, which is finding missing terms of a sequence. Let's say I give you two terms, and I was like, what's the middle term of this geometric sequence? You're going to figure that out. We've already done it for arithmetic, so we can do it for geometric. All right? These are the steps. If you're on the video, make sure you pause. Oh, and then one more thing, kids. On this step right here, I made a mistake. Not a sub 1. See how it said a sub 1 here? Did y'all write a sub 1 here? Yeah. Please change that to say a sub n minus 1. Forgot to write n minus in there. Minus 1. So again, a sub n is equal to a sub n minus 1 times r, and then we're saying what a sub 1 is, okay? So please fix that really quickly for me, and we'll start. Alright, here we go. Number 1. So I'm just going to do two problems here. I'm only going to do one, and we're going to do one together because it's pretty simple and straightforward. Oops, my bad. Okay, so in number 1 we have negative 4, 8, negative 16, 32. Okay, we already know this is a geometric sequence because there's a common ratio that's being multiplied. What am I multiplying each one by to get the next number? 2 or negative 2? Negative 2, right? So we know that our common ratio is negative 2. Okay, that's all we need to do to get our recursive formula started. So the recursive formula says that any number in the sequence, or a sub n, any number will be equal to the number before it times the ratio. Our ratio in this case is negative 2. And then we'd say a sub 1, or the first number in this sequence, is negative 4. And it's negative 2, right? Does that make sense? Okay, so what did I just do one more time? What I just did is I figured out my common ratio. If I wanted to make the recursive formula, common ratio is negative 2. Then I'm literally writing a sub n, or any number in the sequence will be equal to the number before it, or a sub n minus 1, times a ratio of negative 2. And we're stating that our first number in our sequence is negative 4. Okay? That makes sense? These are the rules. Number 2. Actually, write this down really quick and we'll do number 2 together. Ready, set, go. Next thing. Identify any missing terms. Okay, so we're talking geometric sequences now, so we're not doing arithmetic. But remember last week, or earlier this week, I think, where I said, hey, look, we have a missing term in the middle. How do we figure out the missing term if this was an arithmetic sequence? Recall. Someone raise your hand. How do we do that? Yes, Ely.
You add the 2 outside and divide by 2.
Good. So negative 2 plus negative 32 is?
Negative 34.
And divide by 2 is?
Negative 16. 17.
Negative 17. Correct. Negative 17. Okay, does that make sense? But today we're focusing on geometric sequences, which is we're multiplying by the same ratio, right? So how do we do that? Pretty simple. Let me show you. Okay? You take the two outside terms that are outside of the middle term and you multiply them, and then we have to take the square root of that, okay? So we take negative 2 times negative 32, and then we're going to take the square root of that. So Negative 2 times negative 32 is 64. What's the square root of 64? 8 and thank you, 8 and negative 8, right? Did you all get that? How many square roots are there? 2, right? 8's our principal square root, negative 8 is the other square root. And that is true. There are 2 possible answers, right? Because our common ratio could be negative 8, right? Or I'm sorry, negative 4. What's negative 2 times negative 4?
8.
Positive 8. What's positive 8 times negative 4? Negative 32. Does that make sense?
Yeah.
Okay. Or our common ratio could just be 4. What's negative 2 times 4?
8.
Negative 8. What's negative 8 times 4?
Negative 32.
Negative 32. Right? Did y'all see how we have 2 answers? Turn to your neighbor, explain why we have 2 answers. Y'all got that? Okay, now watch me do number 4. Number 4 looks a little crazy, but it's not that crazy, okay? So we got 3 missing terms in the middle here. We have 2 outside terms, okay? Always focus on the middle one first, okay? So I know that this middle one has to be the exact middle, or if I were to take the square root of these 2 outside terms, I could get this middle one, okay? So I'm going to take 2 and multiply it by 2592. What you might say, oh, that's such a big number. Well, you're all becoming big kids now, so don't worry. And you got, oh, there's your answer. See, that was easy. You just do that and you're done. Okay? No. Okay? So 2 times 2592, we plug it into our calculator, or you could do it by hand. We get 5,184. Take the square root of that. When I take a square root of a number, how many answers will I have? 2 answers, right? We have a positive and negative. So then I go to my calculator, plug it in, and I get the answer is positive and negative 72, okay? Now this is a little confusing. We do need to check if it's going to be positive or negative this time. Is it possible that this middle number is positive? Okay, let's think about it. Our common ratio, let's say, we don't know it yet, but could our common ratio be positive times a positive? This would be a positive. So if this is a positive times the positive again, this would be a good. If this was a positive, this would be multiplied by a positive, this would be a positive. So is it possible that this whole sequence is positive?
Yes.
Yes, good. So positive 72 does work. What about negative? Positive 2 times the negative is? Negative times the negative is? Oh, good. So then, can this be a negative?
No. Yes.
Think about it. Positive 2. Positive 2 times a negative is? Negative. Negative number times a negative is a positive. Is it ever possible that I'll have a negative 72 in the middle? No. Did you all get that? Raise your hand if you're confused one more time. Okay, before I ask again, do you all agree that a positive common ratio would make all of these positive?
Yes.
Would you agree? Okay. So positive 72 has to work, right? Would you all agree?
Yeah.
Okay. Let's make it negative. Positive times a negative would be, this number would have to be a what? Negative. Do you all agree? If this is negative and this was a negative ratio, what's a negative ratio times this negative number? Positive. Positive 72. Did you all get that? So is it possible that this is a negative number? No. So we don't want to include negative 72. Did you all get that?
Yep.
Okay, so why don't you turn to your neighbor and explain that before I move on, okay? That this middle number is a negative 70 or a positive 72. Go. So if we know that middle number is only positive, then these other numbers we still could be positive or negative. So because we already tested it could be both positive and negative. So to find these other 2 plus 72, all we got to do is do some side problems. Actually, there is no positive. Back a tad. Okay, so now we're going to take 2 and 72 and multiply them together to get these 2, right? Yep. 2 times 72 is?
144.
144. That's a nice number, right? What's the square root of 144?
12.
No, not just 12. Positive or negative 12, right? Do y'all agree? Okay. Is it possible that that second blank space is negative? Yeah, it can be, right? So we're going to keep that negative there. So it is possible that it could be positive and negative 12. Now, how do we find this last one? We just multiply 72 times 2592, take a square root, right? And you're like, oh, that's so hard. You guys have calculators, right? Just use a calculator. So you need to start using your calculator to use these to solve these big problems, okay? So when we do that, we get the square root of that will be positive and negative 432, okay? I just did it at one fell swoop, right? That's it. Does that make sense, everyone? Okay. So you kind of have to think logically on some of these problems if it's possible to have positives or negatives, okay? And then that's it. I'm not going to waste your time doing more of these problems because I think you got it. Raise your hand if you're ready to move on to your homework. Okay, raise your hand if you want to spend more time. I think you guys got it. Okay, that concludes this lesson.